Hi friends, welcome to my channel on Theory of Structures. Today I am going to discuss about the solution of a T-section to find out the center of gravity and moment of inertia of a T-section given. I have taken this question from the previous question paper, April 2019 question paper. So here a T-section is given, the dimensions are given, the flange, the top horizontal member, the horizontal part is known as the flange, 100 mm wide and 50 mm thick or depth, and the vertical part is known as the web, W-E-B, web of width 50 mm and height 100 mm. So the dimensions are 100 by 50 and 50 by 100. So these are the dimensions given. The question is to find out the center of gravity of this T-section and also the moment of inertia. So first, today in this video, we will do the center of gravity or centroid of this T-section. You know the difference between center of gravity and centroid? For a plane section, being this one is a plane section, the center of gravity can be considered as the centroid of the section. That means the section is symmetrical about YY axis here. So first of all, you have to check whether the section is symmetrical about XX or YY or both, right? So here the section is symmetrical about the YY axis. What it means, symmetrical about YY means the area on both sides of this axis are the same, right? The shape is the same. Okay, so in this case we have to locate X bar or Y bar being symmetrical to the YY axis. We have to find out Y bar. What is Y bar? What is the formula to find out Y bar? You studied Y bar is equal to A1 Y1 plus A2 Y2 divided by A1 plus A2. What is A1 and A2? We divide this T-section into two rectangles like this, say rectangle number 1 and rectangle 2. So first divide the combination, this T-section, into two rectangles. First rectangle 100 mm by 50 mm, second rectangle 50 mm by 100 mm. Now, as you know, first consider a baseline. Take a baseline either at the top or at the bottom, right? So here I am selecting a baseline AB at the bottom level, AB. Now with reference to this baseline, we have to consider this Y1 and Y2. A1 and A2 are the areas of these two rectangles, number 1 and number 2. So what is A1 equals 100 by 50. This rectangle, area of the first rectangle, 100 into 50 equals 5000 mm squared. It's the area of the first rectangle. Then A2 equals 50 into 100. 50 into 100 equals that also 5000 mm squared. Areas are the same. Now the distance Y1 and Y2. What is Y1? Y1 is the distance from the datum line, the baseline AB, to the first rectangle, the CG of the first rectangle. The CG of the first rectangle will be at a distance of 25 mm from this point. So total will be 100 plus 25, 125. So Y1 is equal to 125 mm and Y2 is the distance from the same baseline AB to the CG of the second rectangle. That is, from here it is 50, right? 50 mm. So y2 equals 50 m. a1, a2, y1 and y2. Now substitute these values in the equation. Therefore y bar equals 5000 into y1 125 plus a2 is again 5000 into y2 is equal to 50 mm divided by a1 plus a2 5000 plus 5000, right? That is the distance. Y bar means the CG of the whole figure, the CG, the center of gravity or the centroid of the T section about the same datum line AB. That means this distance is Y bar. So that Y bar, when you calculate, you will get the value that's equal to 87.5 mm. 87.5 mm from AB to the center of gravity. That is XX, and this one YY, two axes, XX and YY. So when you get a question like this, T beam, I beam or Z section or channel section, whatever it is, first you have to check whether it is symmetrical to which axis, symmetrical to XX, YY, or it is unsymmetrical about XX and YY both. So in that case, if it is symmetrical to YY axis, take Y bar. If the section is symmetrical about XX axis, then take X bar. X bar is equal to A1 X1 plus A2 X2 divided by A1 plus A2. If it is unsymmetrical about both XX and YY, in that case, find out both X bar and Y bar. Right? In the case of a, for example, in the case of a channel section, in the case of a not a channel section, in the case of an L section, suppose an L section like this L section is not symmetrical about XX or YY. So you have to locate both XX and YY, both the axes. Understood? Then only you can locate the CG of the whole figure. So this is the method to find out the center of gravity of a figure, combined figure, by dividing into rectangles. Okay, I think it's clear. Now we stop here today. Now the moment of inertia of the same section we will discuss in the next video. Okay, thank you, one and all.